So here's number 9 for section C on the combined gas law. And it says a sample of propane occupies 250 liters at 125 kilopascals and 38 degrees Celsius. Find its volume at 100 kilopascals and 95 degrees Celsius. So our combined gas law is P1V1 over T1 equals P2V2 over T2. So those are all the variables. My biggest suggestion is first things first, go ahead and write out all those variables. The easier you make it on yourself, the easier these problems will be. Make it all nice and clear. So the first thing we see is 250 liters. Liters is a unit of volume, 250 liters. 125 kilopascals, kPa is for pressure, so 125 kPa. And 38 degrees Celsius. So there's all of our initials. Find its volume, so V2 is our unknown. At 100.0 kPa and 95 degrees Celsius. So the absolute first thing we always have to do is convert to Kelvin. So we're going to convert both of our temperatures to Kelvin. So 273.15 plus 38, we get 311.15 Kelvin. Convert T2 to 73.15 plus 95, and we get 368.15 Kelvin. The other catch with our combined gas law is that we just have to make sure our units match from our initial or our ones to our final or our twos. So for pressure, we see kPa, both for 1 and 2. Volume, we see liters for 1. There's no unit for 2, but since it has to match, we know that liters is going to be the unit coming out. And then both of our temperatures are in Kelvin, which means we're good to go in. So 125 kPa for our P1. V1 is 250 liters. T1 is 311.15 Kelvin. P2, plug that in, 100.0 kPa, kilopascals. V2 is our unknown. And then our other temperature is 368.15 Kelvin. So there's a lot of ways that we can do this, but what I'm going to do first is I'm going to just go ahead and cross multiply. So make sure you write everything down. So 311.15 Kelvin, 100.0 kPa, and don't forget that V2 equals, cross multiply that other side, 125 kPa, 250 liters, 368.15 Kelvin. So let's go ahead and simplify before we start pulling things over, all that kind of good stuff. So let's simplify the left-hand side first. So 311.15 times 100 gives us 31115.0. Keep those units. It is Kelvin times kPa times V2. Over on the other side, we can multiply it all together. So we got 125 times 250 times 368.15. We get a huge number. It's going to be 1150467.5. The unit is kPa times liters times Kelvin. Huge number. If you're confident in plugging this all in your calculator, I would just recommend doing that too. Now we're just trying to isolate V2. So equal and opposite always. So we're going to divide both sides by 31115.0 Kelvin kilopascals. 31115.0 Kelvin kPa. So we'll get V2 by itself divided by 31115.0. And we get the new volume as being 369.75. So we cancel kPa, cancel Kelvin, and we're left with liters. The other way we know that it's liters coming out is because we plugged in liters, so liters is going to come out, so our answer is 369.75 liters.